Let's talk about X-ray. So starting from this video, it will be the HL part of option C, and let's take a look at what we need to know first, right, before we move on to X-ray. So here is a study guide from the official syllabus, and let's take a look here. So basically, there are a few kinds of medical image. Apparently, this is the name of C4. And there are mainly three kind of medical imaging. The first one is X-ray, which will be covered in this video. Second one is ultrasonic or ultrasound, which there will be probably the hardest. Actually, it's still not very hard, but a little bit complicated calculation involved. The last one is called the NMR, okay, nuclear magnetic resonance. Okay, and so if you try to look at what we have, you can see I try to label in 3 color, and you can see X-ray is here, ultrasonic is here, and MR is here, and of course we have to compare between all 3. Actually, all 3 of them. I don't think it's only these 2. All 3 of them. Okay, and so for this video, we'll talk about X-ray. So there are a few terms that we need to know, and also its attenuation problem. Okay, so before we start, I will want you to watch a video, and I will put the link in the description, and you can try to take a look. So basically, it's telling you how in the history this guy find or discover the X-ray and how we make use of it. Okay, it's a really nice video from EdTech. I'll put the link in the description. Also, there is another video to show you a more technical way to see how we can produce X-ray in the lab. Okay, and so here is the setup, and again I will want you to pause the video and watch this video also before you move on, right? Because only when you understand how it's been operated, then you can understand how we use it in medical imaging. Okay, so pause the video now and watch 2 videos. Okay, so after you watch these 2 videos, I think you get much better understanding on X-ray. So as I said, we will talk about X-ray in this video, and so I will want you to firstly read a few pages. So try to read C 4.1 and 4.2, which basically is about the qualitative part in X-ray. For attenuation, it will be 4.3, which I will cover in the next video. So on your textbook, I want you to read basically that would be page 35 to 37, and try to look for this. Okay, so I basically extract that from the lines here, and you can see there are quite a lot of keywords that you may pay attention to. So including attenuation coefficient, half value thickness, linear or mass absorption coefficient, and how to improve the sharpness and contrast. Okay, you may not see all of them, but when you see those terms, you may want to pay extra attention. Okay, so pause the video now and try to read these 3 pages first. Okay, from 4.1 to 4.2. Okay, so let's talk about, or let me go through some keywords with you, key ideas with you, so that you at least see if we all have the same, keywords or key point highlighted or underlined. So first of all, for X-ray, the first page 35 here is not a lot. It's more like introductory. So it said, and also from the video, especially this one, you can see that you need to have a very high voltage in order to produce X-ray. Okay, so here is that you need around 15 to 30k volt and 50 to 150k volt. This is basically talking about the mouth. So if you ever went to dental, I think around your age, probably you might need to to have an X-ray theme for that, because you know, in Cantonese 智慧齒 you may start to grow maybe by 18, or some people may get it later at 20 years old, maybe when you get into university. And some people, actually quite a lot of people, they would somehow grow in a not very good way. I mean, some people they will have a lot of pain when they grow it, and therefore usually we take X-ray and then see whether we need to remove it. Okay, you may actually ask your parents, see if they have removed it or not. All right, and nowadays we usually use a lot of these technique, X-ray, to see whether it's growing well or not, because apparently you cannot see it. It's quite embedded inside your mouth, so you can't see it directly. So for chest, it would be higher voltage. Apparently you don't have to memorize the voltage. It's just to show you that different voltage will show different intensity. If you recall, in these two videos, they mentioned that for a higher intensity, you need to apply higher voltage to simply get, I think in this video, to get a simply higher intensity X-ray. So for chest, because you are trying to shoot the X-ray through your body, so it would take simply more intensity to go through in order to see whatever you want to see, basically the bones of your chest. Okay, and from a medical point of view, you don't want to have a too high dosage of X-ray, because as we all know, too high dosage of X-ray or even gamma ray, it may cause you cancer also. So there is actually a certain control. I mean, for as a normal ordinary person to go for medical check is fine, but for a doctor, for example, who work with X-ray, there is actually a subject I'm pretty sure some of you know, and you may have thought about it. In healthcare, there is a specialized, I can't remember the name, special expertise for doing the radioactivity stuff, right, in medical. Okay, so and here I think I try to use some letter. You can see C1, C2, S1, S2, S3, and also B1 to represent for different features, like how you edit photo. If you ever edit photo before, you know there are a few adjustment you can do, like for example contrast, you can adjust the sharpness, and you can adjust the brightness, and they are not the same thing. Okay, so that's why we give them different name. So for contrast, apparently the first thing is simply the thing you are trying to see, they have a different atomic number. So that is why for bones it's harder for X-ray to penetrate through, while for soft tissue like your the flesh, it will be much easier. Okay, and that's why that makes a difference in terms of X-ray. Here there is another way to increase the contrast, so I would recommend you to label like how I do, is to use something called a contrast medium, and here they use something called barium meal, which is barium sulfate. You don't have to memorize this, but I think the idea of taking up this, as you know, swallowing this, will be quite useful. Okay, and it would absorb X-ray much more strongly, and that's how it can make the contrast even better. The second thing is called the sharpness in terms of the photo properties, and there are three ways if you ever pay attention to the paragraphs here. And the first one is to use a point-like source. Okay, as a diagram here shows, if you use a not as point-like, what they call it extended source. In fact, point source, you know, as you have studied physics for so long already, you know point source is an ideal idea. Right, there's nothing is literally a point, but here it's just saying that it could be much the more pointy it is, the better it is. Okay, so for the normal light, of course, to a certain extent there will be an extend source, and that actually would make the shadow more blurry because there's something called the umbrella effect. And that would be the first one. The second one is like if you look at these diagram, you can see let's say the patient is lying on the bed here, and then for X-ray, of course, you need a film to get the photo capture. So that's why we put a film underneath, all right, at the back of the patient, and it said it will be the best if the film is as close as possible to the patient. At the same time, relatively speaking, it will be the same as if the distance from the source of the patient is large. That means here it will be as large as possible. It will be good to be a further distance. For this one, it will be the best if it is as short as possible. Okay, to illustrate this, actually you can easily, I took a video here. I seldom do that, but I think it's just easy for you. You can try it at home as well. Just try to get a source of light, and then you can see, try to pay attention to my shadow here. There was a light coming from the top right, basically, and you can see my table is like the theme. Try to capture whatever can be seen, and you can see that if my hand is away from the table, the shadow is becoming more blurry, and if it is closer, you can see the edge is very sharp in that case. So I hope that would help to explain the reason. Okay, you can see now it's getting more blurry again. So that will be the idea. And at the same time, if you think about so why would it be better if we move away from the patient, then actually get back to the idea of this, all right, then it would be more sharp shadow in that case also, all right. It will be less of an effect of light going in different angle like this to the edge. Okay. And the third thing you can do is, okay, so this was the second. The third thing you can do is you can use something called a grid of LED strips, okay, which is illustrated by these two diagrams. So for a diagram like this is without the grid, and what happened is scattering in chapter 8, and as the X-ray go to the patient will absorb it. It will also scatter away, and that will cause a problem because when you scatter, it actually go in any kind of direction. So that would affect the sharpness of the photo. And so what you can do is you can apply, as we said, the grid of LED strip, which looks like this. And this is simply a really physical, brutal way to solve the problem, is to basically making tunnels. All right, 1 tunnel, 2 tunnel, 3, 4, 5 tunnels. All right, and apparently in the real situation there will be more. All right, it's not just sci-fi. But then the main idea is so that the X-ray can go in only one direction. If you try to scatter, then it will simply be blocked by the LED. All right, so imagine, let's say here, it will try to only go in this direction. If you try to scatter in this direction, and basically that would simply be aiming at the LED. And if you remember in year 10, LED was one of the best absorbent for radioactivity or ionizing radiation. If you remember, we talk about alpha, beta, gamma, and then alpha could be stopped by paper, and then beta could be blocked by aluminum foil, and gamma ray kind of blocked, but around 50% blocked by a thick piece of lead, I think 2 cm thick of lead. And so apparently lead was basically the best material, most handy, of course, material that we find. And of course it's very dense, that's why it can help to absorb a lot. Okay, And if you try to move on to the paragraphs, and the last part here is talking about you may use something called the double-sided theme. More precisely, it's called the intensifying screen to increase the brightness. Okay, so be careful with the idea here. This is increase the brightness, not contrast or sharpness. Okay, I do think there is a difference, because brightness, if you try to simply get your Instagram, right, take out your phone, go for Instagram, try to draft a photo, and then there should be an edit button you can change, and then you can see the difference between brightness and sharpness and contrast, right? And they are totally different. And so for this one, what the intensifying screen is doing is actually very smart, I would say. It's because for the theme, like how you take photo, actually not you guys take photo, your parents taking photo. In the past, you know, nowadays when you use phone, like with the camera, I think 99% are all digital camera. All right, and in the past, we have we don't have, before we have digital camera, we have the theme, like really traditional way. So basically a photograph where when you get light exposed to it, then it will leave a certain pattern on it, and that's why people, after they took the picture, they have to go to basically the Photoshop for printing out the photo, and in Cantonese it's called size. Basically put you into a dark room and try to expose the theme. Okay, so and it's simply a physical property that the theme is more sensitive to the visible light, you can see here, and so this material is very interesting. That what happened to it is when X-ray shines on it, it would scatter, and then it would scatter visible light. So basically it's just more like an amplifier, because basically it changed the X-ray into visible light, and that visible light is just simply more efficient in exposing the theme underneath. So this is to help you to increase the brightness. However, does it increase the sharpness or contrast? It doesn't. All right. That means if somehow your bones and soft tissue are more or less the same density, making it brighter won't help you to see the difference. It's still one chunk of whole, bones and soft tissue all together. Same as sharpness. If there are so many lights going in different directions, making this light brighter doesn't help anything. Okay, so I mean it may help a little bit, but not help a lot, basically. So that's why brightness, contrast, and sharpness are three different things. Okay, so I don't want you to mix it up. The last thing that they mention, in fact, has nothing to do with the three photo properties. Is called fluoroscopy, and it's something to do with taking the X-ray in the real time. I don't know why they mention it. I don't think it is in the syllabus. However, yes, I don't think so. And but let's just take a look. I mean, it's just a very simple idea. So what it does is simply having the X-ray exposed on the body for a longer time, and in that case it would be able to see what happened on your body, but apparently I don't think anyone would do that nowadays, because as what mentioned here, it would give the patient a high dose of radiation, and apparently you really cannot receive too much X-ray. See if I can Google it later on, how many X-ray photo you can take. But this one is, imagine you simply just imagine you take video by taking a lot of photo. So this is a similar idea. So instead of doing this technique, there is a technique called CT scan, all right, computed tomography, and basically this is a similar idea of this, but then in a more, I should say, worthy way. That is, this can give you a 3D idea. So what it does is, I think it was shown in this video in the later part. All right, there's a video, I think around 30 seconds, showing you how it looks like, and basically it's scanning through your body. all right, and the way it's shown is more like a spiral way. And then by doing some mathematics, and that's why mathematics is actually very important anywhere. That's why we always promote STEM, not only physics but also mathematics. So when you talk about the geometry or trigonometry or even matrix or vector, all these things help to produce a 3D image, right? Because imagine you take a lot of 2D data, how to construct it and make it 3D, all right? You have to do a lot of transformation in maths. So this is something you have to do in order to make the first ever CT scan. And apparently it will be very useful because there are times where maybe people have to do some surgery and don't know what happened in the body, and you're doing a CT scan, it will be a more thorough scan. And of course the disadvantage would be it will also give you a very high dose because you are taking a video instead of a photograph. Okay, so here I find one, and there are a few things that you may want to take a look. Again, it's nothing to do with exam, but I think it's good for you for your life in general. Okay, so first of all, as we said, X-ray. I think I said somewhere at a point in the past that from the outer space there is X-ray also. Okay, and that is how much dose you receive. The unit is microsievert, MSV. All right, sievert is the unit, microsievert. So it will be 2.4 every year. You cannot escape it. Everyone on earth you receive that. For the US regulations, the maximum annual dose for the radiation worker will be 50. So imagine 50 is something that you may start to think it may start to harm you, but not as really that harmful. It's like marginally. Okay, and of course if you're not a worker, you shouldn't receive that much anyway. So you can think about this. Like people may worry about doing the airport security scan, and I'm pretty sure you experience that also. And in fact, you can see the dosage is very little. It's as little as eating 2 or 3 bananas. Okay, so it's really not much. The other thing that you may take a look is the X-ray, like medical X-ray, and then you can see it's not a lot, but you can see CT scanned will be a lot, like 10. So if you do like maybe 4 times of CT scan together with the average background, you kind of already met the limit for a worker, all right, in US already. So apparently CT scan is not something you should always do. You can't say, oh, I just feel like to check my health condition and go for a CT scan. It's not only about your money, but also about you may probably make a healthy body into a terrible body instead. All right, so think about that. And yeah, I think these are basic some ideas. And one interesting thing is smoking will actually cause a lot of radiation to your lung, and that's why people, if they smoke a lot, they would easily have lung cancer, and that's why smoking is always a very terrible idea.